Good morning, everybody. This is Song-Yan Zhou from Platform Computing. I would like to thank you for joining the session. And the topic today I'll cover is cloud management, particularly private cloud management. What I will cover in the next 50 minutes or so is first the processes that we have observed to be effective in building a private cloud in enterprise environment. I will use a few examples to illustrate what's involved for running a private cloud, from the phases of discovery to experimentation, testing, POC, to deployment. Also the business considerations behind that. After we've gone through that practice orientation, I will spend some time to discuss how some of the products for cloud management for distributed applications middleware from Platform have been used to build and run and manage private cloud to support applications, and discuss with you how these products have been built and used in this context. So just a very quick preamble on platform computing before we get into the topic. We are neither a large software or systems company in the IT industry, multi-billion dollars, nor are we a startup. You have seen many that just got created over the last 1 to 3 years to capitalize on cloud computing. Platform computing has been in the field of providing management and infrastructure software for distributed applications running in large-scale shared environment for over 18 years, since we started in 1992. And 9 out of the global 10 largest companies are our customers. And we have been providing large-scale systems management to allow these enterprises to share resources across enterprise over the last 18 years. So in the recent 3 years, we have expanded our focus to supporting a cloud environment, and the main reason of that is to support more applications beyond the initial technical computing HPC applications. And the focus has been on the large enterprise around the world, which have multiple line of businesses, and we want to help all these different line of businesses, users, and applications to share computing resources across an enterprise environment. So after this session, tomorrow, we have another session at 10 o'clock Eastern Time, where our product management and the technical folks will share with you more detailed specifics about this multiple line of business shared cloud. But let me focus on the business side and go through the adoption expertise and best practices we have developed with our enterprise customers over the last 2 years. So the evolution of cloud computing actually came from 2 dimensions to converge onto the enterprise. One is the, as you will know, Google, Amazon, these large internet service providers that need to run very large-scale applications, oftentimes new applications, in a grid environment or now cloud environment, and they don't need to go to the proprietary architecture of large servers in silos, but rather they build commodity cloud environment. But even before that, since the 90s, the enterprises have been sharing resources fairly large scale, but primarily running HPC or high-performance computing applications. These are the electronic companies, manufacturing, including automotive, aerospace industry, financial services that does a lot of computing for running analytics, risk, derivative or mortgage or currency pricing, risk applications. So from there, the enterprises are now expanding to sharing resources across enterprise, primarily focused on business applications, right? And this is the main topic I'm going to cover today. So very, very quickly, I think everybody probably know, but just to confirm that we're on the same page. The main reason for people want to get into cloud computing away from this client-server silo type of architecture where resources are guaranteed for individual applications, but resources are also locked in the silos and cannot be shared. Also, as a result, when you need to deploy a new application, you need to build a whole stack, right? The main reasons for people to move to cloud computing are really two. One is to increase agility and innovation to be able to rapidly obtain resources to do what they need to do and running the applications, right, rather than taking months to get servers. Second is to share resources so that they can dramatically reduce their cost rather than every server is running at 10% capacity. So given these two reasons, what we have found is that for enterprise IT organizations, a number of challenges need to be overcome. Right. First is, given that it was silos before, applications running in line of business on their own servers, they have been owning and operating their own environment. So it's a major cultural change. And the low utilization need to be dealt with. The adoption of VM has been a major advance to allow the applications to be more dynamically allocated resources and run it. But the evolution and adoption of VM itself is a major effort. And operations and management of IT environment for cloud is very different from the client-server environment because you want to have self-service, because the system has to be far more responsive. The bulk of the management has to be first simplified, second automated, and third standardized. Right? So many challenges. And when you look at a cloud, it's large-scale resources, all kind of different applications to share. Therefore, you cannot really count on any vendor, including platform, of course, to provide a whole cloud system for you. And you need to be careful not to get into vendor lock-in situation. So let me now get into the adoption, but going backward, starting with sharing with you a couple of user examples to see some of the dimensions of the private cloud adoption. And then we can go into the adoption process that are common to these use cases, as well as many others that Platform has been working on. So this one is a top insurance company headquartered in North America. Okay, very typical situation where they have very large VMware installations, many VMware clusters, and the main problem they had after they have successfully virtualized their infrastructure and allow a bunch of applications to run in these servers, oftentimes shared, and achieve the server consolidation, is that it still takes weeks to get resources from IT because it's a manual process, and the cost is still high, even though there's some server consolidation. Utilization of the VMs is still low, and the hardware resources still low, poorly utilized. A lot of management is done manually, so therefore cost is high, and even after people have used their resources, oftentimes they are not reclaimed, so idle resource hang around. Virtual resource or physical resource, still the kind of same scenario. So what we did, if you look at the diagram on the right, is that we introduced a new layer of software above, beyond all the hardware at the bottom, and also the VM layer that goes with the OS and servers and storage. So the new layer is cloud management, the particular product, Platform ISF, that virtualizes, but not one server, but across a whole bunch of resources, even in some cases, in this case, can be multiple data centers, to have all these resources accessible to the applications. Now, the applications in this case range from test and development, because this insurance company, as you can imagine, has thousands of developers developing all kinds of applications, used both internally by the insurance agents as well as by the customers being served online. And therefore, they need VMs and the resources to test their code and deploy their code. So the test dev is a very common but a very good case where the resource usage is very erratic, sporadic, and therefore you really don't have dedicated resources. But in this case also, the applications are developed on application servers, such as WebSphere here. So the middleware is also supported, and in fact, based on the infrastructure level service by Platform ISF, we are able to support the this insurance company specific platform as a service practice for them to build their own platform with embedding their own middleware and run the application in that context so that developers can be focused on the application development, not worry about runtime lifecycle of applications. And in turn, we provide cloud management to manage the lifecycle of all the resources and running the applications. So the support for this insurance company from a cloud management point of view is both to provide the infrastructure service layer, to provide VMs and resources to do the test dev, for example, as well as to integrate and support their middleware and their platform as a service layer to support their applications execution, both internally and externally. Now, in the future, they also expect to have more and more of these cloud services to supporting their external customers who go online through the web and obtain insurance services. So it's a SaaS model. This company, in that regard, is really like a software company, right? Except they deliver insurance services, they do insurance business for casualty and life, but main way they do that is online, is through software they deliver to run services to serve their customers. So this large-scale environment that are expanding, starting with a fairly modest production environment they are running now to a larger scale, is evolution that's going to happen over the next half year, 1 year, 2 years. Now, what have been the results so far? Well, I think as you probably hear from many other cloud examples, if you implement this automatic self-service, you are able to achieve dynamic provision resources, therefore reducing the provisioning time of the applications and resources needed from weeks to minutes. And that also enables them to move fairly fast in their development without having to go through the manual process, therefore improve the productivity of their developers and reduce the cost of IT. So this, I would say, this insurance company case is a mainstream case where they evolve from client-server silos to massive adoption of VMware, to now escalating to the next layer of managing the whole resource environment, integrating with the application through cloud management. This is not a case. It's more complex because it's not a private company, but rather a leading government contractor in the U.S. Because they're a government contractor, their business is really not one business, but tens of business serving all kinds of government agencies, whole bunch of three-letter agencies. But even serving each of the agency is not one project, but rather multiple projects, multiple pieces of work. And because these are all different businesses at different level of security, they have been running very dedicated hardware resources in not only each business line for the agencies, but also even programs and projects within those business lines. So basically their infrastructure and administration is duplicated across hundreds of these siloed line of businesses and programs within the line of businesses. Same result of long delivery time, and really nobody has global visibility as to how resources are used and shared. So they took a different angle to try to create a centralized, corporate-wide cloud to run the data center and have the resources there securely delivered to all these different groups and programs and line of businesses. So therefore, a natural requirement they have is multiple levels of hierarchical self-service, both supporting end users as well as management administration. So not only do they have the central cloud managers, they also have line of business managers that are there to manage the use of the resources for different line of businesses to support their users and to budget the usage so that it's not free for all, right? So these are now working very well. The response time is now less than a minute for a regular request by the end user to obtain services from a line of business within a program, including all the security checks and permission checks. Administration cost in this central cloud data center is much lower than the client-server mode, and the performance capacity is now substantially improved. So again, this is a case where they are now aggressively trying to expand the installation to support more line of business and users while maintaining all these benefits. So now, given these two mainstream enterprise private cloud use cases, let me now go through the best practices that platform computing has developed in working with over 100 of such enterprise customers. The private cloud, as you can see, is a very different mode of operations. And it's also supposed to be simplified use of the resources from end user point of view. So the challenges are primarily on the management, operation, IT side. For the end user, it's supposed to be transparent and simpler and easier and self-service, right? So let me now focus on the 4 steps that we find enterprise need to go through to get to a production private cloud. These steps are first, discovery to learn what is cloud and how it applies to your business, to your applications, and based on that, zoom in on the target use cases you want to implement, not Uber cloud for everything and everywhere, right? And based on the use case establishment as well as the business applications, then you need to source some partners, vendors as partners, because you need to work with the vendors closely at this early stage of market to run the proof of concept, to establish the value. And as that's successful, then you can do the requisite procurement, go through the UAT process, and start getting into production. So let me go through especially the first 1, 2, 3 steps. So first, let's just look at the background, right? Cloud has been oftentimes associated with VM, and cloud can take advantage of VM, and VM is very important for cloud computing. But it's quite clear after 2 years of experiences working with many enterprise customers that cloud is more than VM. Cloud is the next natural evolution stage after people have adopted VM. In fact, after people have adopted a lot of VM so that they already moved from client-server environment to a virtual data center with VMs running on many machines, probably multiple VM clusters, multiple vCenter, right, to be a part of the enterprise data center. Call it virtual data center. Cloud data center has some major new things, such as automation of the processes across these clusters, many different applications, orchestration of all these resources, and automation of application lifecycle, and then dramatic large scale above beyond individual VM clusters. Right? So as James Staten from Forrester mentioned, that VM is a good step in a way, but it's not a whole enchilada of cloud computing. Right? So that mentality is very important in thinking that have we done some good work with VM and have some form of VM data center, virtual data center? If so, you may be more ready to do cloud, but cloud is a different initiative with a different orientation, but can leverage some of the expertise and people you have in building up the VM environment. So when I say cloud is new, this is illustrated in the IT stack here. So the legacy stack is fairly simple. You have servers at the bottom that runs applications, and there may be some application middleware or infrastructure in between, and then you have the traditional enterprise system management to run the whole environment. What we have found in the cloud data center environment is that you typically have a whole bunch of commodity resources, x86 with VM and OS to go with them, servers, storage, and interconnects, and you want to run the same applications, maybe new applications. You have some application infrastructure, but then the new layer here in green is a cloud and management tools to go with the cloud infrastructure layer, right? So it's something new. Now let's look into it deeper. So what is new here, right? What is new is what we call this cloud management or open cloud management that is really sitting in between of all the supplies of your hardware resources and all the demand from your business units and applications. So this cloud management layer is really a new layer purpose-built to manage these cloud data center environments, because you want to have this layer to be general purpose, able to run and support all kind of applications workload on the top to serve the demand, but also able to integrate different heterogeneous resources that are needed by these different applications. So it's a general purpose layer interposed between supply and demand, integrating resources and running the applications. Not only that, because you want to share all these resources, the cloud management not only have to automate the provisioning self-service process, but also match the IT resources to the application demand. So it needs to be knowledgeable, smart about workload, It need to be expert and knowledgeable about all the resources it need to harness to deliver. And oftentimes, because the workload is changing all the time, you need to be able to dynamically flex and change the resource allocations to serve different application needs and while meeting the service level requirements. Okay. So as we saw earlier in the enterprise environment, this cloud management need to enable business units to share resources across the board, but as if they have the dedicated resources to them. When they need it, the resources are there based on their service levels, but if they don't need it, it can be shifted and share for other applications. So to do that, above beyond what I mentioned about sharing, about integrating and supporting applications, there were all kind of issues that need to be dealt with for IT operation management, right? So for the IT to deliver service level, to run the whole cloud behind the scenes, the cloud management is a key layer of software to ensure that security is maintained, the governance, regulations, compliance are kept. I mean, the way the resources are used, the way applications are run, the policies are enforced, and it should be open architecture, as I mentioned earlier, because in one cloud you run all kind of applications and different hardware used. Therefore, it's not imaginable that a single IT vendor would deliver all this to you. And be very careful in terms of IT vendor lock-in, because that will constrain you from being able to run some applications in a vendor-specific cloud, but not others. And you may end up having multiple clouds that are vendor-specific, therefore become a cloud silo type of environment. Okay? And one example of that requirement to avoid the vendor silo and lock-in is that you need to be able to integrate your cloud operations environment with some of existing tools. Maybe you already have the security or compliance software, and you need to integrate. Right. So now, let me make the statement that the biggest barrier of cloud adoption is not really the technology. It's not really cloud management. It's really the other two P's beyond the product, the people and processes. Right. So first, the cloud is about large-scale sharing and tied to the business, but run by IT. Therefore, top-down executive sponsorship from a business point of view is very important for a cloud project to be successful. Now, also the end user buy-ins are very important. Otherwise, there simply won't be any demand. They will continue running the application in their own silos. Right. Now, if you focus on IT side, it's also an opportunity as well as a challenge to transform IT from cost center to service center and have all the governance issues worked out. It's not all day one. It's a learning process, and it's a growing process, but it does not need to be done systematically. So let's now look at some of the applicable use cases for a private cloud. There were a whole bunch of them, but here we have mentioned a few that have been used by our customers. I mentioned test and development. I mentioned a whole bunch of web applications, web services, right? It can also be fairly simple infrastructure service to do whatever, not just test and development, to run other applications. What we found is that the analytics applications that require a lot of resources, the demand are very fluctuating, is a good class of applications to run in a cloud environment. And of course, Platform has been the dominant player for providing management software for HPC applications in the clusters and grid type environment, and now cloud. So the point here is that there are multiple different use cases and applications that are suitable to run in cloud, and you need to really look at your business, your applications, to decide which application is the most benefits and least risk and efforts to try cloud on, and to go through the production experience, and then you can expand from there. It may be VDI put into the cloud, maybe your own third-party production applications. But I would say in picking the use cases, we need to be careful to go through evolution and not start with difficult ones, mission-critical ones. Maybe you don't want to use the heavy-duty transaction-based, database-centric applications to run in the cloud. They may never go into the cloud, right? No architecture, including mainframe, client-server, and cloud now, is universal, applicable to all applications. So with the background of the discovery, of identification of the use cases, you are gearing up to be ready to try cloud out by running a proof of concept or proof of value. So there, our observation is that the most critical thing is to focus on your customers, on their applications, to really get a clear picture of their requirements and why they need to go into a cloud and what are the expectations. And in terms of expectations, I think it's very important to have a improvement to be expected, but not to set high expectations. For example, you don't want to set up a big cloud initially. Control the size to be manageable, maybe just a couple dozen servers, right? And also try to have this as a new test, to have some dedicated resources, both on the hardware and the system resources, but also a team, maybe a small team, right, to work on these projects through the duration of the proof of concept, right, to make sure that people are aligned both on the user side as well as IT side as well as executive side, and define a project schedule. Typically what we found is that if you are reasonably well prepared, it takes about 4 weeks, maybe up to 2 months. It shouldn't be too long. If it's too long, it may mean you're not ready, or it's too complicated, or you're trying to do too many things. So be careful, focused, right? And also, in the best practice managing a project, make sure you have the documents for the project plan, but also compile the results of your business case and results of your proof of concept to make sure in written form people are all aligned on the results, have the same perception, therefore you can lead a group and users forward step by step. So the core of the POC is focused on the use case and business case, based on the use case now, right? So in terms of business case, what we observed is that the specifics of the business case depend on the use case. But there are typically two approaches to justify why we should do cloud and why is our top priority in IT, why it's going to make impact on our business. First is strategic justification. I mean, all the things I talk about, the silo, low utilization, long time to provision, all those things really impact business, right? Therefore, oftentimes the biggest return is not even quantifiable or need to be quantified. It's just I'm able to deliver results to users so much faster. The speed, agility, and customer satisfaction means that cloud is transformative. But oftentimes that strategic justification is good but not enough. What are the hard ROIs? What are the cost savings that can be achieved? Fortunately for cloud, if you look into it, it can substantially reduce your operational expense, and it can substantially reduce your capital expense. Operational expense can be reduced because a lot of the user demands are now self-service and automatically delivered resources. Therefore, the number of servers per admin can be increased from a few dozen to 100 to 200 or beyond. Therefore, you can dramatically reduce the system management operational cost. Also, on the capital expense side, typically cloud enables you to use more commodity hardware, more commodity resources. Therefore, the cost can come down there. But also, because of sharing and increased utilization, the capital cost of purchasing all this equipment, including sometimes software licenses and services, can be substantially reduced to reduce the overall cost. Okay? Now, the last thing about why you may want to identify some management software products from vendors rather than building a cloud and writing code yourself is typically quite open and easy. That is, this is fairly large-scale, complex environment. And your business is probably your insurance business, your government services, but not really software, but maybe application software, but for sure not the system management software. So for long-term cloud operations, it's really not a self-built, self-developed application and management software case. So therefore, the adoption of vendor products and the right vendor product become a critical issue. Okay. So therefore, I think the use case could be a combination of strategic justification as well as classical ROI in terms of reducing costs both on the operational side as well as capital expense side. So now let's imagine that we've gone through the discovery, we focus on the use cases, we had a business justifications, and we run the POC, and that's quite successful. right? And if you do the first preparation stages, what we experience is that the POC is really just a proof, meaning validation. And maybe you find a couple software glitches, vendor need to work with you. Maybe you identify a couple new requirements, application integration or management integration with your management tool, and the vendor need to rapidly respond to you before and during the POC for you to have a successful result of the POC, right? But after that, the real game starts. The real game start is to start deploying your cloud stack with your applications into a production environment. There you need to go through a regimented, disciplined UAT process, go through the security audit and so on, right? But that ends into a small production environment. Call it pilot to be just modest in our expectation, right? You want to start small, but now the same applications, maybe more applications you tested in POC, are now being brought into production, running in this cloud environment rather than your client-server environment. Okay. But there, again, the key advice is to go through steps, maybe rapid, small steps, but don't do a giant leap forward. To implement applications in stages, to deploy more and more cloud management capacity capabilities in stages, and to introduce more capabilities such as reservational resources or bursting resources to external cloud, not just internal cloud, to have more flexibility and elasticity of resource delivered to the applications, even during the application running. Right? For example, when web applications are running, you can add and subtract resource to the same application installation in response to the traffic volume of the web requests. Right? Clearly, chargeback reporting, all those issues are very important to have good visibility by management, by IT operations, as well as your customers, how cloud are used, how services are delivered, and how much resource are consumed, therefore how much somebody needs to pay. Okay. Now also, the production is not just one shot. Only after you've done the POC, you can now start seeing concrete way the adaptation you need to make over time for the IT processes, for your policies and procedures, right? As I mentioned earlier, this cloud is an opportunity for IT to transform itself from just a cost center to an internal service provider. And there, you need to build and train your cloud operating team, same stuff you have, but in an integrated way, not some administrator running network, another administrator running server only, because everybody on the team need to look at holistically as a cloud data center delivering end-to-end self-service, right? What are the metrics that you need to establish with end users for the application service levels? All these need to be worked out and over time expanded. So now then, if you step way back, in terms of cloud adoption, we have gone through this before in the HPC space called clusters and enterprise grid. It's always multiple steps, starting with application server silo on the right to the shared infrastructure across enterprise on the right. So the silos on the left, the shared infrastructure on the right, but there are multiple stages. The point is that it's evolution over time, it's evolution over multiple different applications, multiple locations. Therefore, the management need to support, the cloud management needs to support all these different stages away from the server and application silo into a more and more holistically corporate-wide shared environment, even leveraging external resources. So oftentimes you may want to have multiple siloed clouds, partition environments, and then you start collapsing this cloud into fewer clouds, into fewer installations, and then eventually integrate them across multiple data centers around the world. Okay. So in that regard, I'd like to share with you a third use case and call this not evolutionary, but revolutionary. In fact, we had a webinar with this user a few weeks ago available from Platform's website. This major bank took a revolutionary approach to implementing cloud for several factors. First, they took a top-down approach, starting with the applications, not with the IT resources, infrastructure service, right? Second is that they took a holistic approach of architecting, deploying the cloud, led by the CIO, sponsored by the CEO and the board. Third is that they were focused on this large-scale operation environment on some of the most mission-critical applications they have, right? So let me talk a little bit about the business of this bank. This bank is one of the top custodian and portfolio services management bank in the world. For custodian bank, they are providing extensive financial services market and the country and defense and natural disaster information to their corporate clients, thousands of them worldwide, so that they can leverage all the extensive information that they were not able to amass on their own to assess the risk levels, the value of the property they have. That's why it's custodian banking, right? And that's $17 trillion under custodian services. And so therefore, from that point of view, this bank is almost like a Google. It's Google for enterprises. It's not like you and I go through a browser to do a Google search, but rather they are enterprise customers still go through the same browser, HTTP protocol over internet to get to these banks' services and do their custodian banking services to get intelligence as to what's going on with my asset and what do I need to do now that the stock market just closed in New York. Right? So they have been delivering these services through hundreds of Java applications they implement by thousands of developers and providing these services online through these application services. But they have been doing that through thousands of Unix SMP server silos. Right? Each application, each service runs their own hardware, and they have massive replication of all these hardware silos running applications. So as a result, when they need to deploy a new service to serve their customers with a new clever idea, they have to build a whole stack, right, as we talked about earlier. So high operating cost, long delivery time, in this case, directly impacting their businesses, impacting their ability to rapidly offer new services in a changing market to have more customer services, more satisfaction, and more revenue and more profitability, right? So the first issue they got is not really the cost of IT. The first issue they got is the effectiveness of their getting more businesses, because business is first and foremost about making money, not save money, right? Second issue they have is that the thousands of developers they have to tackle all kind of operational infrastructure issues, and they want this developer to be developing their applications in a standardized environment, only writing application code, the Java beans and the runtimes, but not really worry about the platform layer, platform as a service, not worry about infrastructure resources and operation running of the applications issues. So they have established their own platform as a service layer, in this case based on Tomcat and JBoss, and they need systems infrastructure to support their platform as a service. And that's where Platform ISF come in support, as you can see on the diagram on the right, of the application infrastructure, application layer, server layer, to run all the applications in a shared infrastructure rather than each application running in their own silos. So the key benefit they are looking for are first, a rapid time to delivery of the services to deploy. Second is at least doubling of their developers' productivity by simplifying and standardizing the operating environment and application platform so that they can focus on developing their Java code. And third, significantly but third, is to substantially reduce their IT cost. Right? But the bottom line for this bank is to ensure that they're delivering service levels and general service level for all these services from end user point of view are very simple, same as Google. 2-second web response time end-to-end, even including all the security, customer checking, allow what service you subscribe, what data you can access when you hit the bank's service site, right? So you still have to deliver turnaround time for the web response 2 seconds. Also, 100% availability. What that means is that if some data centers, entire data center goes down, the service has to continue, right? So therefore, the cloud that this bank has spans multiple data centers, and there's active to active failover in the multi-data center scenario without any special traditional technology for HA, but really it's just exploring the intrinsic high availability potential of distributed computing. If one data center is down, we simply switch over all the requests to another data center that are also duplicating, running the same services, but also underneath all the customer databases, data warehouses are synced up. In this case, based on Oracle and based on Golden Gate technology. So there's some work at the data layer to ensure that data is replicated, accessible across multiple data centers. Then the cloud management software that Platform provides is now doing all the rest in managing all the resources, allocating them, managing the life cycle of all the web service applications, and then serving the customer requests across multiple data centers around the world in a transparent manner. So the benefits there are quite common again, is that deliver these service levels, but also reduce the cost substantially, expecting to now over time reduce capital costs by 50%, maybe even more. And also the stack is quite open, allowing them to choose different OS, different VMs, and the different application middleware. And also our management for cloud is integrated with other tools, so it's not locked in there either. So this, I would say, is the future of as much as possible enterprise computing to mimic and look more and more similar to Google, Amazon, and Yahoo by having these applications that are stateless, that are horizontally scalable, to take advantage of this large-scale, elastic distributed environment using both internal resource hardware, but also be able to go to external resources, but still maintain a private cloud environment for its security, for its compliance, for its value-added cloud services by the IT to support their end users in an enterprise-specific way, right? So we have talked a lot about the cloud computing, and people say, why couldn't I just run applications in Google or in Amazon EC2? It's better, faster, cheaper maybe, but I couldn't for all these reasons. Now, in this case, it's clear that they can get the same kind of service levels. They can get the same kind of paradigm shift to run Google, but for enterprise. And oftentimes, in many cases, we have seen even cheaper. Because if you go to external services from time to time occasionally, it's much cheaper than you're owning your hardware and leaving them idle most of the time. However, if you are able to use your resources 60%, 70%, 80 or even 90 or 95% time, then you can even get cheaper services to your customers, but with additional value add by your enterprise IT. Okay, that's proven over and over again. That's why in the HPC space, in the major banks, in the automotive aerospace companies, they always use their internal commodity hardware because they get much better service supporting applications and even cheaper because they are able to use the resources in a high utilization rate and highly available and accessible. But it still enables you to burst out to external resources, especially for peak demand, that you don't want to keep resources around for one time or two times a year. So let me now spend some time talking about the products from platform computing that have been used to run cloud. I mentioned the product Platform ISF several times. This is the front and center product to run the cloud, but also there are a few other products involved. So this Platform ISF is positioned to be an open cloud management software. It's one product, custom built to run cloud environment, distinct and separate from client-server environment and enterprise management software there. This is a new generation. Cloud computing is a new paradigm. Therefore, Platform, with our experiences in running large-scale shared environment in HPC in enterprise, start about 3 years ago to evolving bulk of our technologies to build this ISF product, but also to integrate with the VM technology, with automatic provisioning software tools, and to have an open architecture so that this cloud management can tie into some existing tools you may need to use in your management of your data center. So this Platform ISF, looking up, it creates one computer for multiple applications across your data center or data centers, right? So it's a cloud computer management software, right? It's looking down, it's integrating different hardware and software resources, heterogeneous OS, VM, as well as hardware, storage, and interconnects, because these resources are needed by the application you want to run. We neither dictate what application you run, We don't require you to run our own proprietary middleware, nor do we dictate what VM and OS you use, because we're not an OS or VM vendor, and therefore we are vendor neutral on both resource side as well as application side, and providing this layer that's open cloud management to enable you to build one cloud across your data center. Okay. Also, the approach we took is not to glue together a whole bunch of existing management tools, put a web portal for self-service on top of it, and voila, that's the cloud solution for you. We found that approach to be overly complicated, to be relying on management software that was never meant to be used by a cloud environment and support self-service, because those management tools from enterprise management era of client server were really tools bought and used by enterprise IT. Now we're trying to automate everything so that we don't need to involve people in delivering resources self-service. Therefore, the technology involved, even though some of the buzzwords are the same, can be quite different. For example, at the bottom, this resource integration layer was not there. You were running a bunch of silos before. Now you are trying to integrate them together. So the bottom layer we have is almost like the flip of VMware VM. VMware VM allows you to create multiple virtual machines out of a single physical machine. And then we are here, resource integration across a distributed environment, to allow you to create one machine, one virtual machine, out of many physical devices, including servers, storage, and interconnects. So this is the foundation of the cloud management required to build from there. But the heart and the brain of the cloud management is the second layer up above the resource integration. That is the policy and allocation engine to orchestrate and allocate and arbitrate the resources upon application's resource demand, so that sharing is happening in ordered fashion and the service level can be met. Then above this allocation engine layer, a lot of technology need to be there to interface to the applications, therefore can support the life cycle applications, including multi-tier applications, and also operational support for reporting chargeback, for operational management of the IT, and then for the workflow in multiple steps of provision resources, delivering services, including approvals that may be needed for management to control how much resource, what kind of resources can be delivered to the end users, so that it's not chaotic and free for all. So, a bunch of key concepts. Let me quickly hit through, right? First, integration with VM, in particular VMware, which is dominant VM technology in the market, is critical. It extends naturally from VM, but introduce a distinct new layer. Second, in the multi-line of business enterprise environment, this hierarchical self-services, allowing different line of business, different program projects to manage their own services, is very important. Third is that it's not really, are you here to provide support for infrastructure service or platform as a service or software as a service. It's the cloud environment supporting all these different layers and different levels of services, from infrastructure to multi-tier applications, integrated with various middleware, such as all the Java middleware, such as the messaging middleware, such as VDI infrastructure, and so on and so forth, right? And the fourth key point about Platform ISF for cloud management is, again, this heterogeneity, right? Multiple VMs, physical machines versus as well as virtual machines, as well as enabling people to go external cloud while still having the security, compliance, and management for the private cloud management. This rapid provisioning flexing is given, and then in an enterprise environment, multiple data centers need to be integrated, and from an administration point of view, this cloud cockpit that is part of ISF allows you to have zoom in and zoom out capabilities across all your assets, your users, your line of businesses, your applications, and of course, your resources. So let me just give you a glimpse, very quickly, eye chart of the cloud cockpit as a graphics-focused end user as well as administration interface to Platform ISF. Right. So here you can see multiple panes that give you different views. Maybe you want to look at hosts, physical or virtual. Maybe you want to look at VMs. Or maybe you are now looking at the public cloud resources as well as your internal resources, right? So the resource view is across the board and can be tied into existing tools that you have for management. We're not here trying to do everything. It's more of a manager of managers to tie into your vCenter for virtual machine management, to tie into your storage virtualization tools, and to tie into your security compliance tools, to invoke those before we run the workload. Okay. So here, this diagram shows the quota setting and configuration and setup of different resource templates, as well as application profiles that will be available to the users and enforced in the multiple line of business environment. And these interfaces can be used by not only the central cloud administrator, but also by the line of business managers in controlling their own users' usage of resources and managing their own budget. So the control can be delegated to multiple levels of management and operations to serve their end users effectively. So now we're looking at applications, right? Here we show an example of WebSphere. It took a few hours a day to set up the particular application profile that describes how this multi-tier application with database tier, application tier, and web tier should be set up, and so that when user made a request to run application with WebSphere setup, the whole deployment, activation, resource allocation life cycle can be automated. And even after the WebSphere application has started running, resources can be added and subtracted to the application tier based on the traffic. But it allows you to specify, look, the database tier needs to run in the physical resources, not VMs, tied closely to the same environment, whereas the application tier can be run on maybe it's a KVM VM because it's cheaper than VMware, and should be minimum of this many machines. But if the service level drops, you need to allocate more virtual machines and more resources to run the web application tier, and so on and so forth. So it's very flexible, it's application specific, and become part of the offerings, portfolio of application service offerings you can deliver to your users. So the application focus for cloud over time is going to be critical because the industry is so much fixated on infrastructures and resources and delivering VMs. But keep in mind, in the end, the majority of the enterprise users are not there requesting 3.5 VM to play with. They are not there doing sandbox. They are there running applications. It's just underneath applications you need to allocate these physical and virtual resources, but those should be transparent and virtualized and automated. Therefore, the application-centric view of the cloud, in the end, is the most critical and business important. So this is kind of a summary view of the, on one screen, you have a single pane of glass for your administrators of cloud, for your line of business managers to both look at the hierarchy of resources, zoom in, to look at different kinds of users, applications, projects, line of business, as well as resources. But also on the right-hand side, you can pick and choose a bunch of sub charts for the performance metrics that are critical to you. But most of the time, I hope you don't have to look at them because everything's green, because the management of a large-scale distributed environment is by exception. You don't have to be a watchdog watching over your resources all the time. They are working, and if something's not working, then either they self-correct based on procedures you set up automatically beforehand, or they allow you to intervene on an exceptional basis. So let me wrap up the conversation here today. I know it's been fairly long, and it is a lot of material. In the next couple of minutes, let me wrap up. So the cloud is about supporting multiple different type of applications in a shared environment, and therefore the cloud management layer needs to be open and supporting all these different scenarios. It also needs to deliver integration and support of different levels of cloud services from infrastructure all the way to SaaS, right? And in that regard, there's another layer of software on top of cloud platform that enables applications to run in a distributed environment. So this is distributed applications middleware and management workload. It's not only the Java applications, can also be distributed parallel SOA, can be distributed processes of applications, distributed batch applications, and the MapReduce as unstructured data analytics is becoming more and more important, and by nature it's distributed. If you look at the Google, the big application is its Hadoop running MapReduce protocol, and we support all these different applications through the application middleware, and the application middleware running the applications can in turn sit on top of the cloud platform to allow all these different applications to share in a large-scale enterprise data center environment. So the architecture are layered in supporting the application on one side and running IT on the other. And on the right-hand side, the Cloud Manager are some of the simplified IT administration tools for monitoring, reporting, analysis, troubleshooting, but they are much simplified from the client-server era of enterprise system management tools. So here we show a number of products from platform computing, from the industry, the leading LSF for batch, to Symphony for distributed parallel SOA, and to platform MapReduce. So I will skip the platform MapReduce and summarize this conversation by telling you first what we found to be critical in the cloud. That is the consolidation, still maintaining control, right? To make sure that cloud environment is comprehensive and the management software is purpose-built for cloud so that it's not constrained from the legacy technologies point of view. And the architecture you build need to be centered around your businesses, your applications, and consider your multiple groups of users and multiple locations with an open architecture that can extend, expand to add more capabilities, support more applications over time. And of course, the cloud management for private cloud management for enterprise need to be scalable, high-performing, and enterprise class type of setup. So I think that's all the material I would like to deliver. As I mentioned at the beginning of the hour, there's a second session from Platform Computing tomorrow, Thursday, at 10 a.m. Eastern Time. And also, you're most welcome to come to Platform website, www.platform.com/privatecloud, where there's a lot more material to provide to you, and we are here to support you. We offer 30-day free trial, and we can offer a lot of advice and consulting for you free of charge as you are going through your adoption process of cloud, from discovery to establishing use case to run the POC and hopefully get into production. So with that, I would like to wish you success in your cloud projects, and the Platform Computing is here as an experienced distributed computing management software company to work with you and support you to achieve success in cloud computing. So I think we're running up to the hour, and I'd like to thank everybody for coming to this session and spending time with me. Thank you very much. Goodbye.